Okay, so we're continuing with this idea that the integral of f of x dx gives some function capital F of x, and that function is the antiderivative of f of x, or the other way to think about it is that the derivative of capital F of x, is equal to little f of x, our original function. And so basically when they talk about differential equations in chapter 11, they introduce the concept of slope fields, but I want to sort of introduce the concept of slope fields now to help you understand it. So what I'm going to do is I'm going to draw a set of axes. And I'm going to go I'm going to go 1, 2, 3, 4. I'm going to go out this way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 is going to be 0.5. 1, 2, 3, 4 is going to be 1. 1, 2, 3, 4 is going to be 1.5. 1, 2, 3, 4 is going to be 2. Then I'm going to go 1, 2, 3, 4, negative 0.5. 1, 2, 3, 4, negative 1. 1, 2, 3, 4, negative 1.5. 1, 2, 3, 4, negative 2. Okay, and so now the function that I'm going to graph f of x is equal to 2x. But what I'm going to do is I'm going to say that this is equal to f prime of x. So I'm going to say that my function y equals 2x, let's just sort of do that. Well, I'll do it. 1, 2, 3, 4, 0.5, 1, 2, 3, 4, 1, 1, 2, 3, 4, 1.5, 1, 2, 3, 4, negative 0.5. Okay, so roughly speaking, 2x is going to, we're going to look something like that. Okay, but that's f of x equals 2x. But I want to take the integral of that. So what I'm going to do is I'm going to make a slope field. So that's the slope of a function. So I'm going to say that when x equals 0, f of 0 equals 0, so that's capital F prime of 0. The slope of my integral at 0 is 0. So I'm going to draw all slope lines. So these are slope lines, and what that's saying is that at 0 the graph is horizontal. At 0.5, if I plug in this f of 0.5 is equal to 1, so here at 0.5 I've got a slope 1. So I'm kind of trying to draw the diagonal as best as I can. And then you can see that at negative 5, I'm going to get a slope of negative 1. And at 1, I'm going to get a slope of 2. So it's going to be like this. So I'm drawing lines that have a slope of 2. And then over here, I'm going to have a slope of -2. And then at 1.5, I'm going to have a slope of 3. And so 3, that's going to be like, I'm going to do it like this, roughly speaking. Here's -3. Let's start there. So I'm trying to draw a line, have a slope of -3, and since I'm freehanding it, get a little bit of variation. What I'm trying to do is try to like 1/3 that way, 1 way, and 1/3 that way. So I've got like 2/3 of a box divided by 2/3. Rise of 2 divided by 2/3 gives me 3. That's how I'm sort of thinking about it. And then okay, so these are slopes. So a function that at this point here slope 0. Now when it gets to this line, got a slope of 1. So the 1 there, and slope of -1 there. So the line has got a slope of 2, and when it gets over here, it's got a slope -2. And when it gets over here, it's got a slope of 3. Get over here, it's got a slope of -3. And so I find sort of following the slope that if I say that my function 2x gives f prime of x, then I'm coming up that capital F of x is equal to squared. What I've just sort of shown is that the integral of 2x dx is equal to, and that's something that you guys should know already. Sort of think about what I'm saying in that video. Now, I could also start here, and I could go there, and like there, and like there, and I could come over here, there, there. So I could also say that the integral of 2x dx to x squared plus 5. Similarly, go up to here, and I could do this one. And I could show that integral of 2x dx x squared plus 1. So this is where we get the plus c. The integral of 2x dx is going to be x squared plus c. Because my derivative, if I say that f of x is the derivative of my integral function, then I just make slope fields, and that I've got the same going all the way up, and so I can take different lines. I can take this line, or I can take this line, or I can take that line. So there's something for you guys to think about. And next video, I'm going to jump up and do it on the computer so you see it a little nicer by freehand drawing.